prediction. And related to the soil analysis, these are all the different works they have used for soil profile mapping, soil electrical conductivity determination, soil pH determination, soil classification, soil tool interaction, soil temperature. These are all the works based on the soil analysis. And in the precision agriculture, for crop yield monitoring, grain storage characteristics, corn yield and grain quality, these are all the different research works are published related to the precision agriculture. And on chemical applications, what is the nozzle wear? How long we can able to use a particular nozzle with a different pressure and discharge rates? That work was done by me and Krishnan in 2002. In 1997, the pesticide concentration was determined using feed-forward neural networks. These are all the works which are available in the literature. And now I'm going to present what work we have done at IIT Kharagpur using artificial intelligence and the sensor-based smart precision farming. I'll go as a stage by stage. First one, the first operation, like uh, soil preparation or land bed preparation for feasible growth of the crop. Here we have used artificial intelligence for finding the power source efficiency. Here the power source is the tractor. We know that most of our in country, 31 to 40 HP horsepower tractor segment is used, and 45% of the total sales are in this particular zone. And in our country, as per 2018 statistics, 7 lakh 90,673 tractor units were sold and 60,000 power tillers were sold. And there are more than 24 tractor manufacturers are there. And the important thing is that the fuel consumption in the tractor. It is contributing about 16 to 45 of total machine cost, fuel consumption. And that is why our aim is to determine the fuel consumption of the tractor for different tillage operations. If you see the engine of the tractor, the engine is having some characteristics. The engine speed versus the fuel consumption, if you plot, we are getting a different throttle settings. We need to choose in which throttle setting I have to operate a particular implement. Suppose I'm using MB plow, what kind of gear and throttle setting I need to go? And if I'm going for any cultivator, what is the throttle setting and gear I need to select for having a maximum productivity? Based on that, we could able to give an advice to the farmer or a tractor operator, he can able to set that. The fuel consumption is having effect of different sub operations like tractor maintenance. The proper traction is also influencing the fuel consumption, engine conditions, proper gear selection, implement matching, and operator training and skill. These are all the different factors which are influencing the fuel saving. We have made a effect and cause analysis, and based on that, we could able to consider that engine speed, throttle setting, and PTO power are the major input parameters. If somebody wants to use AI or artificial intelligence, we should understand what are the effective input parameters which are going to influence the response or output. Here, the response is torque or fuel consumption. We have considered the PTO power because we need to make a model for different tractors. We have kept the throttle setting, thereby the operator can be given an advice that operate at this particular throttle setting, you can have a minimum fuel consumption. The engine speed, yeah, sometimes as we give a load, means I'm operating with MB flow at different soil conditions. Based on the soil condition, the draft will be more and the load will come onto the engine, and it is going to change the engine speed. That is why engine speed, throttle setting, and PTO power we have considered. And finally, we are predicting the engine torque and fuel consumption. And this is the prediction result using generalized ANN model. We could able to get the different uh, speed drop, what is the actual and predicted torque, and what is the actual and predicted fuel consumption results. Also, we could able to show it over here. And one more thing is that using the ANN model, we could able to map at a different engine speed, what is the throttle setting, and based on that, what is the fuel consumption we are going to get. That particular model we have developed, and we have compared with the actual data also. You can see here, this particular point, it is at 9 liter per hour. That is exactly coming into the prediction of the contour 9 liter per hour. Uh, this is the result we got. Using the ANN model, we could able to get an accuracy with an error of 3.95% error. And this is the Harris model. It is only for one tractor, 8.03. And using ASAP model, we got 39% error. And we have generalized the ANN model also for different tractors. It is giving us 11.31% error. And not only the power source related to the implemented draft, also we could able to make a ANN model. And here, 20 to 55% of the tractor power is available. The interaction between tire and the soil. Because of the different soil conditions, the power requirement is going to change for the tractor. And we have used ANN for predicting the draft requirement. The PTO power, tire overall diameter, wheelbase, total mass of the tractor we have considered as input, and drawbar pull at 15% slip. As per the Budini test reports, it is indicated the tractors are compared at 15% slip. And what is the drawbar pull? And this particular ANN model we have used. And this is the generalized ANN model for different tractors we have developed. And we have compared with other models also, like Brixis model. If you see this, the Brixis model is giving 22% error for predicting the draft requirement, whereas the generalized model is giving only 4.9% error. From this also we can understand that the statistical, compared to the statistical models, the ANN or AA models are giving less error. And related to the sowing of the crop, for a cotton crop, we have used again EA technique. This is our pneumatic planter. What is the vacuum pressure we need to keep, and what is the spacing between the cells onto the planter? That particular analysis also we have done using EI. Here we have taken the shape of hole, size of hole, vacuum level, ground speed as the input parameter, and the output as quality feed index and precision index for planting of the crop. We have mapped with the input parameters. We are compared with multi-layer perceptron neural network and radial basis function neural network. The radial basis function neural network has given a good prediction compared to the multi-layer perceptron neural networks, with the error of quality feed index about 0.4994% as a mean average error. And the R-square values also you can observe that the RBF model is giving a best fit compared to the multi-layer perceptron. These are all the prediction results for training data and testing data. And we can also observe that the prediction of radial basis function is exactly matching with the experimental data. The same thing we can observe in terms of the multi-objective optimization also. We could able to see that what are the different input parameters for having a maximum quality feed index and a precision index. The next thing, the important thing is intercultural operations. We can use the artificial intelligence techniques for crop disease identification. As we know that as a crop, it is affected with bacterial diseases, fungal diseases, and viral diseases as a pathogen of bacterium or fungus or virus. These are all the symptoms. This particular understanding is very much required while using artificial intelligence for mapping the result. Here, the another kind of artificial intelligence technique, like as a convolution neural network, as an object detection algorithms, we can use. Till now, using the data, we could able to predict the results. From now onwards, we are using the images. Using the image data, we could able to see the health condition of the crop. If we consider an input image, it is having 3 dimensions. One is height of the image, width of the image, and number of channels. Here, the number of channels are green, red, blue, red, green, blue. 3 channels are there for RGB image. We can get 3 channel information, and also height and width, the pixels along the length of the image and width of the image, the pixels are also there. Considering this data, we can able to go for a convolutional neural network to analyze whether the image of the leaf is healthy or diseased. Importantly, the convolutional neural networks are more important neural networks which can able to apply using the artificial intelligence. Here we got different layers, like convolution layer, we have pooling layer, and we have the dense layer. I can show you what are the different operations of these layers are also there. The convolution layer means we got a image data. For example, we got R channel, red image intensity values are there. And this is like as a matrix, 5 by 5 matrix. We don't understand anything from the matrix of general image. And to understand this particular value, we are going with the known matrix. And this one is called as convolution matrix. Once we convolute, that means convolute means multiply and add the both the things. You can see that the elements are multiplied and added together. and thereby we are getting the sum of the elements over here. And this particular operation is called as digital convolution. And using this particular convolution operation, we can reduce the image size from 5 by 5 to 3 by 3 with a more information. The information is got indexed over here with less number of values. The next thing is the pooling layer. In this particular matrix, we can see the average of a submatrix or maximum of a submatrix. This is called as pooling. We can further reduce the size of the matrix either going with maximum pooling or average pooling. Means we are doing as a pre-processing for the data. What is the raw data we got? We want to tune the data using the different operations like convolution and pooling. Once it is tuned, we can go for the activation. As I've indicated earlier, as a artificial intelligence or artificial neural network, the activated weighted sum of input and bias is called as neuron output. Here the activation function is ReLU function, rectified linear unit function, or positive linear function we are going to use in the convolution neural network. For understanding its performance, we got different performance metrics like precision, recall, accuracy, intersection over union, average precision, or mean average precision. These are all the different performance metrics we can use for understanding the accuracy or capability of the developed model. We have used a potato disease identification, mainly considered only 2 disease classes and 1 healthy crop class. The diseased is early blight and late blight. We have used 2,101 images and 311 images were considered for test data set. The image size is 256 by 256 pixels along height and width, and 3 channels as red, green, blue. 3 channels are there. We have used only the RGB image. We have not taken any hyperspectral or multispectral images over here to just check whether we could able to get a good result with AI or not. And as I've indicated, the training platform is Jupyter Notebook. We have used with 15 epochs or training. Learning rate we have considered as 0.001, and batch size is 16, and optimizer is Arden optimizer. These are all the things, parameters for a model. Like in regression also, we need to go with the different parameters of the samples and all those things. Similarly, in ANN also, we need to go with these parameters for fitting the best model. And we have compared the performance with the 3 types of object detection algorithms like YOLO V3, single shot detector, and FastRAW CNN. The images we have considered from the local field images as well as plant village dataset and plant dataset images also. We have done data augmentation annotation, and with that we got the data size of 2,200 images for training, 550 images for testing. And once we make the data, we need to annotate. For annotating, we are using a bounding box. Wherever there is a disease of a particular class, we need to classify that manually initially for training the network. And we have used YOLO algorithm, darknet framework on Google Colab platform using GPU. Image size is 416 by 416 by 3 channels. Total steps we have considered 20,000 steps with a batch size of 64 and learning rate of 0.001. And for single shot multi-box detector, we have used the image size of 300 by 300 by 3, 35,000 training steps we have considered. Batch size is 32 and learning rate is 0.001. And for FastRAW CNN network, again, we have taken input image size of 640 by 640 by 3. 50,000 steps we have considered with a batch size of 12 and learning rate we have taken as 0.003. Not only the identification of the disease, we have even quantified what is the severity of the image using the image processing technique. Here, the severity we are given in the range of 0 to 1. 0 means there is no disease at all. 1 means 100% disease is there. The severity index is in the range of 0 to 1. The formula is given as 1 minus area of the healthy plant region divided by area of the full plant region. Using the image processing or AI technique, we could able to identify where is the disease, how much area is occupied for the disease, and what is the rest of the area, the healthy crop zone, we could able to identify. Now, area of the healthy plant zone, we can able to get divided by the total area of the full plant. Full plant area minus healthy plant area, we are going to get as the diseased area. Diseased area divided by total area, that will be the severity index. Here you can see we got the potato crop image using the image processing techniques. We could able to take out the background or even using the YOLO algorithm also we could able to get this one. Once it is separated, in this one, how much is the disease zone? Using the bounding boxes, we could able to get the diseased area. Diseased area uh, uh, divided by the total crop area we are going to get as the severity index. As a performance wise, for the disease severity detection, you can see the precision is 100%, recall is 99%, F1 score is 99% for potato early blight. For the late blight, the precision is 98%, recall is 98%, and F1 score is 98%. And for the healthy crop, 94% is the precision, 100% we got for the recall, and 97% we got for the F1 score. This is the training accuracy and validation we could able to observe. As we increase the number of our training steps, the accuracy is also increasing, whereas the loss is reducing. And for YOLO V3 model, we got 85.3% precision with a total loss of 0.207% at the end of 20,000 iterations. This is the mean average of precision of single shot detector and also the first CNN. The single shot detector has given 84% mean average precision, whereas first CNN it has given 80.2%. You can also observe here, we could able to detect the disease. What kind of disease is that? You can also see that if late blight, it is showing over here as LV. We could able to observe that using the convolution neural networks. And this is the comparison of three algorithms. We got best performance using YOLO V3 model with 70.15% during testing phase compared to the single shot detector 65.9% and faster CNN 66.54%. And one more advantage with the YOLO V3 is that it takes very less time. And that is why it has become more popular compared to the other algorithms. You can also see the image results over here. And in terms of the severity also, once we give this image, it is showing that the severity index is 0.04. That means 4% severity. It got in 0.02 seconds. And in this case, it is 22% severity. And in this case, it is 98% severity. We have used the drone also for capturing the images on the crop. Particularly for the chili crop, we have used this particular drone, which is having 48 megapixel camera. Its flight time is 34 minutes and the flight distance is 18 kilometers. Using this particular drone, we captured the images. We have made data annotation, again classified the data into training, validation, test data set. And finally, based on its performance on two algorithms, FASTA CNN and YOLO V5, we could able to do the disease detection on chili crop. This is the chili crop image. The manually we could able to annotate the disease, what kind of disease is that. And we have used GPU Tesla T4 on Google Colab for doing this particular analysis. The parameters are the image size is 640 by 640 pixels and 3 channels. Batch size is 64. Learning rate we have taken 0.01. The optimizer is SGD of gradient descendant optimizer we have used. Again, I have given the performance metrics like precision, recall, and F1 score. Intersection over unit. I have mentioned the expression also for these performance metrics. You can see the first CNN. It has taken 1,400 epochs for getting the good result, and 1,500 epochs. It has taken 1 hour 18 minutes time, with a class loss of 0.052, box loss of 0.17, total loss of 0.228. And this is the result of mean average precision. We got for leaf spot and leaf curl. These are the two diseases we have taken. 36.7% accuracy which could able to get for leaf spot, and for leaf curl it has given 58.3% accuracy. Overall, for all the classes, the accuracy is 47.5%. And you can also observe here for this particular chili image, it has detected as a leaf curl with different probability. And these are all the images with the leaf spot disease. This is the performance of YOLO V5. We have used the YOLO 5 algorithm over here with a class loss of 0.0034 and box loss of 0.0613, 800 epochs. The YOLO V5 algorithm, it has taken only 14.4 minutes compared to the FASTA CNN, which has taken 1 hour 18 minutes time. And this is the evaluation matrix. You can observe that the performance of different metrics like precision, recall, FN score, and mean average precision we have gained for least squat, leaf curl, and all classes. And this is the confusion matrix. We got a good accuracy for least squat, 0.46, 46%, and for leaf curl, it is 58%. And you can also observe the results for the test images. We got both leaf curl and leaf spot onto the actual field images using a drone. We have used the drone for capturing these images. And finally, it is the summary of the result. YOLO V5 and FASTRA CNN. In this case, for leaf curl, the YOLO V5 is giving better performance compared to FASTRA CNN. Overall, the performance is comparative, but YOLO V5 we have selected because it has taken only 7 or 8 minutes time compared to the FASTRA CNN, whereas FASTRA CNN has taken 1 hour 18 minutes. And not only the disease detection or intercultural operation, we have used AI techniques for fruit harvesting also. We have used the deep learning models for harvesting the fruits, detecting the maturity of the fruit and all. These are all the different algorithms, YOLO V5, V7, V8 we have used. Here, for YOLO V5 algorithm, the architecture also we have mentioned. Total 150 images per second as a video we have captured for detecting the maturity or the stage of the harvesting of the fruit. Initially, we have done the work on apple. We got a project on robotic apple harvesting. Here, different classes of the apple images we have taken with occlusions, shadow, and light, and annotated using the annotation toolbox. And these are all the results for training and validation. And we got a very good precision of 100% precision at 0.822 confidence for detecting of the apple fruit. And finally, we have for all the classes 83% FN score we got at 0.209 confidence interval. Now you can see here when the apples are there, even if the apple is as a bunch also, which could able to detect the individually the apple. And total 42 apples correctly detected out of 51 apples with an accuracy of 82.35% fruits correctly. And we have taken the same thing for the mango also. For the mango, it could able to give about the accuracy of 80%. Now you can see here for different algorithm, the precision is 97%, 100%, and 100%. The recall value are 80% for YOLO V5. And among all these things, we got the best performance for YOLO V8X with a recall value of 95.50 and precision of 100% and FN score of 97.70%. See here, I have kept some of the images where the bunch of mangoes are there together. Actually, here 4 mangoes are there. In YOLO V5, we could able to show only 3. But whereas in YOLO V8X, it has taken all the 4 mangoes detected correctly. And in the second image here, there are part images are there, for part mangoes are there. That one also we could able to accurately detect using YOLO V8X algorithm. You can see this particular thing in the field image, we could able to detect the fruit where the location of the fruit is there, and thereby we can directly go for harvesting. And this is for the capsicum. For the capsicum also, we could able to do the capsicum detection where the peduncle position is there for the robotic harvesting, and whether the capsicum is matured or not. Using the maturity index also we have mapped in terms of the total soluble solids and the texture of the surface of the capsicum. And you can see the result over here in the real-time video. Once we have taken the real image over here it could able to detect the capsicum and its peduncle. And in this case, it could able to sense where is the peduncle. And finally, it can even show the maturity index also. How much is the maturity for this particular capsicum in this result. And as a performance wise, the mean average precision we got 84% for capsicum detection, and peduncle detection 77%, and maturity determination we have got for 61%. With this, I thank you, the team, for inviting me for delivering a lecture on the AI applications and sensor-based smart precision farming. If any queries are there, it is open for the question and answers. Thank you once again.
Thank you, Dr. Rajender. You can unshare, I think.
Yes, thank you.
Yeah, it is very good. Thank you, Dr. Rajender. I think we could understand that it's a very complex problem, but you have narrated so nicely. Initially, in fact, I was thinking that it was going above my head only, everything, because you are trying to compare that human brain and trying to simulate that one in the computer with that mathematical equations and everything. It's really complex. But once when you, I was thinking in between, I think it is better to climb coconut tree rather than go for this artificial intelligence. But after listening to your some of the case studies, yes, there is a lot of applications. So it is really narrated very well. At the end, we could understand what is the kind of potential this artificial intelligence it has in terms of precision agriculture or in understanding the maturity or harvesting time. I think many more applications are there like that. One or two questions from my side. One
Yes,
is that
yes,
actually you said some equations, especially
yes.
for irrigation, pH, nutrient, and everything. These are generalized equations or crop specific equations?
Sir, actually, the pH and all those things statistically, we got the regression models and people have worked on that for finding the prediction accuracy. But using ENN or AI techniques, we got more accuracy compared to the existing the statistical equations.
Okay. And the second thing is, I think you had shown a very nice slide on maturity, that capsicum.
Yes, sir.
Similar issue is there with us for coconut also, in
Yes, sir.
knowing the maturity. What
Yeah.
is your opinion? Because I think we have some issues, especially image based or optical or acoustic, sound based. So we would like to know the exact maturity of coconut in terms of either tender coconut or matured coconut or if different stages. With your experience, if you can guide us in this, I think it would be of great help.
Yes, sir. Sir, as I've indicated, either statistical methods or AI models or ANN or whichever the tools are there, those are all the tools for making a relationship between inputs and output. Here, the input is image of a coconut, output is what is its maturity index output. Initially, we may think that is it possible directly by seeing the image or by seeing the texture of the coconut, whether we can able to know that how much the coconut is matured. Means it is like as a prediction. But if we go with a scientific methodology in this particular predicting the maturity of the coconut, yes, it is possible, sir. How I am going to indicate. We got different coconuts onto the plant. We could able to initially check it is the day one, day two, or whichever the maturity cycle is there, or maturity number of days are there. We can able to capture the images initially scientifically for each and every stage of the maturity of a coconut. Once we capture the image, now we are using the different image processing tools or AI tools to take the features. Features are how the texture is there, what is the color is there. These are all the parameters or features depending on the variety of the coconut. Therefore, the variety is also another parameter. Because once the variety is different, the color is different and the texture is different. That means for a particular defined variety, what is the color, what is the texture distribution we could able to capture, and that one we are going to map with the maturity and one more scientific understanding. That is only the surface level we are doing. Once we cut the coconut and see, and there also we can do the different maturity levels in terms of the total soluble solids or the taste of the coconut water. As anyway, food processing or the horticulture, they can able to give an idea, means how we can able to know the maturity stage of the coconut from one stage to the another stage. And once we get this information, we are making a relationship between total soluble contents, texture of the coconut, color of the coconut. These are all the features and mapped with the maturity index. The maturity index also we can give like 0 to 1. It is 100% matured or 0% matured. In that stage also we could able to map. And at this particular junction, the AI or ANN or statistical regression or any other curve fitting, these techniques are useful. And among all those things, AI technique is more effective compared to the other things because it is having more generalization abilities, sir, compared to the other techniques, and easily we can able to do this particular task.
Thank you, Dr. Rajender. I think before going to the online questions, there are one or two questions in the chat box. One is, how
Yes,
can
sir.
we differentiate disease symptoms with those of nutrient deficiency or hidden hunger by AI?
Exactly, sir. It is a very good question. Yeah. Uh, Rather than me as a modeler or a formulary and power discipline engineering side, um, the entomologist and pathologist, they can easily able to indicate the symptoms or features of a particular disease in comparison with the nutrient deficiency. I also got to know that sometimes the symptoms are almost the same, but there is a small deviation between the symptoms. Either it may be spot or it may be a lesion onto the
Correct.
leaf
I think
image.
that is correct, Rajender, because I think quite often it is overlapping. So that
Exactly,
is why
sir.
we are
That is
trying
what
to
if
differentiate.
yeah,
Yeah.
yeah. So we can able to map it, but the
Yes.
information or the logic or the understanding we should get only from entomologist and pathologist for a particular crop or for particular disease. If
Okay.
such support is there from your side,
Yeah,
surely I
yeah.
can able to use that tool and I can able to differentiate
Sure,
that.
sure. Then one more is it possible to study the level of maturity for underground economic parts, say groundnut pods, potato, even sweet potato formed beneath the soil?
Yes, sir.
Tough question
Yeah,
again.
yeah, very good points, sir. Because which are there inside the soil as a root crops. Uh, the maturity is also giving the indication in terms of the surface parameters. Like the groundnut got matured, we can able to see how
Yeah.
the leaf color is going to change. Those features also we can consider. And other than that, using the other, as of now, I'm mentioning in terms of the images only. Not only the image, sir, we can able to go with the other parameters like soil uh, parameters, even the crop parameters. Initially, we have developed a one sensor. As a crop sap flow, the sap is flowing inside the stem of the crop. Considering that particular parameter also, we could able to give the information that whether the crop is getting a proper water or nutrient like that. Even when it comes to the maturity level also, the sap flow may vary, sir. Considering that parameter also, we can able to indicate as a research idea I'm mentioning, but surely we can work on that and I can indicate what are the different features we can consider for determining the maturity level of a root crops.
Yeah. Let us see if there is any questions online.
Yeah, sir.
Yeah, somebody. Del.
Hello,
Yeah.
Yes, sir, please.
Rajendra sir.
Yes,
It's
sir.
very nice to hearing you, sir. I'm Dr. Mallikarjun from National Research Center on Pomegranate.
Yes, sir. Thank you.
Sir, you might have seen some fruits of pomegranate. They look
Yes, sir.
very nice externally and they are brown inside. That
Exactly,
is,
sir.
one is aril browning and another is heart rot. That heart
Yes,
rot
sir.
is caused by fungal diseases, and aril browning
Yes, sir.
is because of the maturity, delayed maturity.
Exactly, sir.
And sir, we are facing two problems. How we can go ahead with the detection of these two problems using artificial intelligence? Can you put a light on that, sir?
Yes, sir. Sir, as I've indicated also, considering the input parameters or features is an important role in mapping using either AI or other techniques also. As you have indicated that there is internal damage for the fruit because of the two different diseases you have indicated. Yes, it is going to give as an effect in terms of the texture on the surface of the fruit. Maybe it may be red or looking good and all, but there are light small spots are there that are as a user or a consumer, I also observed sometimes by, yeah,
So
please.
many times.
Yes, sir. That we also observed that. And wherever one small spot is there, as a needle based, the small things are there. When we cut during that side, there is a little bit damage of the fruit, or sometimes it got rotten kind of things. Those things are also there. That is only the visual. Other than that, we can go with in terms of the other parameters. Once we capture the image, how much area it is taking, what is its density, at what is the actual density, means what is the actual weight. Using the other sensing techniques like mass or outer surface features and all, we could able to map whether it is internal damage is there or not. That is one thing, sir. And second thing is that not only the RGB image, there are other kind of imaging techniques are there, like multispectral or thermal imaging and all. Once we can capture these fruits, we can able to get a deviation in terms of the response or signals, and through that also we can able to map whether it is a good quality fruit or with other diseased fruit. That we can able to do, sir. But I have not done any research on that. Surely, I think
Yeah.
some cooperation or if such kind of collaborative work is there, I'm very happy to work and we can able to come up with good result.
Yes, sir. Yes, sir. Definitely, sir. We will look forward for developing such.
Yes, sir. Okay.
Yes, sir.
Thank you, sir.
Thank
Yes,
you,
sir.
thank you.
Thank you, sir.
Anyone else?
Hello,
Yeah,
Yes, madam.
good morning. Good morning to all.
Good morning.
I'm Dr. Anjita George and I'm working at the Indian Institute of Seed Science, MAU. So actually,
Okay.
sir, thank you for your nice presentation. And basically, I'm a seed entomologist. So as you know, some of the issues in seeds under storage is like insect pests and pathogens. And so these insects are too small to identify even. And some of these insects are coexisting also. So suppose if you take into consideration cereal seeds, so more than 3 or 4 may be there at a time. And most often the damage symptoms are also overlapping. So
Okay.
how my question is basically how you can use an AI technology for identification of hidden infestation is one point. And another is like whether you can develop some package so like where the AI technology can be used for identification of these insects as well.
Yes, madam. Yes, madam. AI, as I have indicated, it is a tool, but it requires the information. I also got to know that we can even able to see the respiration of the different seeds. The sensors are also available, like ENOS and all. They can
Yeah.
only able to give the variation in the signal. Once we get the magnitude of that signal, the variation, we could easily able to make a difference or may able to identify which kind of disease or which kind of pest or it got infected a particular seed, that we can able to do. And other than that, using the image based techniques or thermal imaging also, the another technique, through that also we could able to detect the disease of the seeds which are under storage, madam. It is possible. In my slide also, somebody has used for grain storage and the quality of the grain, and it is similar to that. We can able to do that one.
Sir, then thermal imaging, X-ray imaging and all, whether we can develop a simple facility at our
Yes,
our
madam, we can
place?
able to develop. Madam, as
Okay.
a storage wise, once we take the sample, that sample we can able to put into our small device where we
Yeah.
can able to take different imaging on that. That is going to give the information as a signal, and through that, using coupling with the AI, even we can able to say that whether it is infected with a particular disease or it is not infected with that particular
Okay.
disease.
Okay.
We can
Thank
able
you.
to do that.
Yeah. Yeah.
Thank you.
We can. I think I can contact you for further development.
Okay, madam.
sure,
Thank you.
Yeah.
sure.
Thank you. Thank you.
So any offline question here? Dr. Hegde?
Hello.
Yes, sir, please.
Sir, actually, it was nice to hear. I just want to know whether coconut, we also attempted to capture the images from the crown region, because coconut, we have to get the image of the affected palms. So I would like to
Yes.
know, if I take the drone image, is it possible to real time, we can say like that, if I flow the drone for 1 hectare or 1 acre, so if I can say that this particular palm has been infected, or this, because 1 or 2 palms may be infected with or this one, whether can we have a real time like that immediately? Can I get, if I, that type of
Yes, sir.
work?
Yes, sir.
will-
Easily we can get that one, sir, using the drone. Because the drone, whenever it is flying, we can able to get its geotagging. And based on the geotagging, we can able to count the tree or locate the tree. And we can able to give that tree also whether which kind of disease is infected onto that one using AI technology. AI and drone technology combining both the things, we can able to get which tree or where the location of the tree, which kind of disease it got infected, what is the intensity or severity of the disease it got infected. Those particular details we can able to get. Sir.
Second, I would like to know whether IIT, whether anybody, because these drones, when we are using for spray, this one in coconut and arecanut, we are facing problem that we want to target to the nuts. If there is, it is below the leaf. If you want to target for nuts, can we customize? Because now whatever the drones available, it will fly only on the top, and we cannot go below this one. And we cannot
Understood.
target is it anybody working on that, and if we can have a collaboration to customize
it
the
is
drone
there.
applications for coconut and arecanut?
Yes, sir. Sir, it is drone and robotic technology, means robotic arms. If we couple onto the drone, then only we can able to penetrate into the branches of the coconut, and thereby we can able to do the spraying. Yes, with some of the startup companies, IIT Kharagpur, I'm working related to this particular technology, not only for monitoring the crop health condition of a plantation crop, but also we are looking for harvesting of the plantation crop, sir. It is under research stage. The things are going on, sir. It is possible.
Dr. Rajendra, in fact, Dr. Hegde has submitted one project to the corpus fund of ICR,
Okay, sir.
wherein I think his idea is to have something like this. I think in which IIT Kharagpur is also one of the collaborative
Yeah.
center.
Sony,
Dr.
I
Sony
don't
is
know.
there.
We have asked.
Dr. Sony is
Yes,
there.
sir.
He's in
Okay,
your,
okay, maybe. Yeah,
Yeah,
he's in
that's
the-
what he
my
was
same
telling.
specialization. Maybe. Okay,
so
sir.
I think you can also join then.
Okay.
Isn't it?
If
So
we
that
get that
collaboratively we can
from-
think of developing something specifically for that this nuts, because they are
Yes, sir.
hidden in the crown.
Exactly.
So exactly reaching them is very difficult. So
Yes.
some kind of arm we have to develop, and either for harvesting or spraying, that is
Yes,
very,
sir.
very useful.
Yes.
Any other points? Suchitra, you want to say something? Yeah. No, it's not on.
So good morning, sir. Myself Suchitra, entomologist. Sir,
Good morning,
recently
madam.
we
Yeah.
have, recently we have attempted to differentiate the whitefly species and the detection model. We are mainly interested to develop the image detection model, sir. And we have used YOLO V5 software for that. And what we have used is the microscopic images of 4 species of whitefly we have used. And we could able to get very good accuracy and precision for the model also. And we have
Yes, ma'am.
integrated the result with the mobile apps, sir. When it
Sure.
comes to field validation, what happens? The accuracy percentage is getting down because of the image resolution. The same problem we are facing for other insects also. How to address that issues?
Yes, madam. Yes, madam. You have mentioned that you are using your V5 algorithm, and while trying that one, have you given the field images or some other images, madam? Laboratory images,
Microscopic.
microscopic laboratory. That is why you are getting less accuracy, madam. If you can able to get, suppose microscopic, you are getting under the laboratory and giving as an index for the image of the leaf or whatever, that you can able to directly correlate with the field images, then your accuracy will be improved. Means you are taking the laboratory and there you are classifying, but your implementation is into the field, I think. And that is why you are getting the accuracy difference over there, madam.
Dr.
If you can
Suchitra.
able to map it properly with the field images, then you can able to get a good accuracy. I hope I have understood your problem.
No, actually, she is telling there is some difficulty in collecting that field images. Is it? Why?
Madam, voice is not audible.
Yeah, what she is telling now, sir, I think there is some
Yes, sir.
mic issue. Because capturing that field image is very difficult because they are
Difficult, yes, sir. I also know.
microscopic.
That is-
So how
Yeah.
to overcome this problem?
Yeah. Once we take with the microscope, whether any features are there on the leaf in real, I would like
Features
to
are
know
there.
only this.
Features are there.
Yes, sir.
Features are there.
The species
once
can
we
be
could able-
differentiated.
Exactly, madam.
Mm.
Exactly. Whatever you are doing under the laboratory with the microscope, you are confirming that that particular disease is there on that.
Yes,
And
sir.
based on that particular disease, you could able to capture the features in the laboratory. Take those features and map them onto the real field images, madam, not as a insect or something, which are very small in size and only microscope is required. That is not possible in real field. I can also understand. But if you can able to map these features onto the real field images features, then you can able to get the good accuracy.
Okay, sir. I'll make an
That is one
attempt.
thing. And one
Mm.
more thing, madam. Nowadays, YOLO V9, V10 versions are there. You can again rework onto this, means retrain with these models. Thereby, you can able to get a good accuracy. As I have also indicated that YOLO V5 only can able to show me 3 mangoes out of 4. But whereas YOLO V9, it is giving more. That means even the development model wise also, you can able to go for the updated model. You
Okay,
can still improve the accuracy.
Okay, sir.
Sujitra,
Thank you.
you
Ah.
try that one and be in touch with
Okay, sir.
Dr. Rajendra.
Okay, sir. Thank you, sir. Thank you very much.
Any other points? Dalia? Pathology. It's on.
Good morning, sir. I'm Dr. Dalia, pathologist. I would like to ask the question in continuation with Hegde sirs with respect to the drone. You have told that automatic identification and monitoring of diseases with drone is possible, right? So I want to know what kind of model will be used. Is it same like CNN? And is there any specificity for the drone? Because we are having a DJ Mawa series drone with us for a surveillance purpose, whether that drone can be used or is that we have to make any customization to that?
Madam, whichever the drone is available, that is we can able to fly and capture the images.
Yeah.
But other thing what we could able to do is that we can able to make our own device and mount onto that. Otherwise, in the existing microcontroller, we can embed our program and we can able to get the process of that. Either any of these two we can do. For example, modifying somebody's drone, which is already with copyright or something. Our suggestion is that we can able to make a small device which we can able to mount onto that, and through that we can able to capture the image, connect this information to the cloud, and there we can able to do the processing. And during real time also, we could able to do any task like disease detection or maturity identification and all, even localizing that, which location it is that, using geotagging and all. That is possible with a small device which we can mount onto that.
Okay, sir. Then what should be the frequency of images or the number of images required for this?
Very good question. It all
Yeah.
depends on the problem what we are going to target. It may vary, but as of now, we have used the RGB image with only video, as I have also showed that for capsicum and all, 80 FPS, that particular capturing only we have done. But for having more accuracy, we can go with advanced cameras where we can have more frequency in capturing the images and all. Those things we can go with that.
Okay, thank you,
It
sir.
all depends on the problem, but we will try with the low quality or the reliable units. If it is not possible, later on we have to go with the higher level like multispectral or hyperspectral imaging or even thermal imaging. The other capturing techniques also we can use.
Okay, thank you, sir.
Thank you, Dr. Selvamani. Anything on soil related aspect? No, you were asking about sensors and everything last time. You ask now. No? Okay. So I think it was a wonderful talk, sir, and very nice discussion, very interactive it was. So I will request Dr. Hegde to, no, Dalia will be proposing vote of thanks. Thank you.
Okay. Good morning, all. On behalf of CPCRA, I would like to express my heartfelt thanks to Dr. Rajendra Machavaram, sir, for sharing such a profound and insightful presentation on the topic of advances in artificial intelligence and sensor-based smart farming. Sir, you have shed light on how these AI technologies will be revolutionizing the way we approach agriculture, which will help us to become more efficient and sustainable and with more data-driven technologies. Thank you so much, sir. Plus, I would like to express my thanks. I would like to appreciate your time and expertise, as well as the clarity with which you have dealt the topic, as well as the discussion sessions you have involved. So I would like, once again, I would like to thank you for your time and expertization. And I would like to also thank all the participants who are available online and offline and for their active involvement in the discussion session. Once again, thank you all.
Thank you, madam. Thank you, one and all.
Yeah, thank you. Thank you.